Hi everyone, this is Algebra 2 for Wednesday, April 1st, 2020. I'm recording this, of course, the day before, but, anyway, that's neither here nor there. Happy April Fool's Day to you. Hopefully no one pranks you. I don't have any pranks for you myself. Sorry, just math. So what we're going to be looking at today is finding rational zeros of a polynomial. So yesterday we talked about dividing, right? And so we're going to go a little bit off of on a tangent here today, but you'll see why we talk about dividing, because we're going to actually use it today in finding those rational zeros. So first things first, the way we find these zeros. So this is kind of meant to kind of like join in together with the idea of factoring that we did in the past, where we divide a polynomial up. It allows us to kind of come up with a list of numbers that we can determine are or are not zeros for our functions. Sometimes we already know how to find a zeros. I mean, for example, if I have like x times x plus 1 times x plus 2, and that's equal to 0, then I know that I can just set x equal to 0, I can set x plus 1 equal to 0, and I can set x plus 2 equal to 0, right? And get, oh, well, there's my 0 there. This will be x equals -1, and this will be x equals -2, right? And voila, I found the zeros. Sometimes we had to do a little bit more work than that. I mean, for example, let's say we had like x squared, whoops, I don't want the parentheses there, x squared plus 4x plus 3 as an example, right? And that was equal to 0. In this case, right, it's not a product yet, so we can't set each product equal to 0 here, but we could factor this thing, right? So we could also use factoring. So x plus 3 and x plus 1, and that's equal to 0, right? Because 3 times 1 gives us the 3, 3x, and 1x makes the 4x there, and we have the x squareds, right? That's what it factors to be. And now we can set each factor equal to 0. You get x equals -3 and x equals -1, and there are zeros there, okay? But what happens if we come across something that we can't factor? We cannot factor, sorry. So for example, I'll find the rational zeros of, and we'll say f of x equal to x to the third plus 2x squared minus 19x minus 20. Okay? Now, if you look at this, right, none of our factoring strategies will work. You could potentially try grouping, right? You could put parentheses here and parentheses here, but there's nothing that factors out of this group except for an x squared, and there's nothing that factors out of that group instead of like a -1, and then your leftovers aren't the same. So all of our normal strategies fail. So do we just give up? Well, you might want to, but we're not going to, okay? So what we're going to take advantage of here is the fact that we're going to come up with a list of rational zeros that could work, and then we're going to kind of guess and check our way through, okay? So let's do this. So how do we do that? Well, what we're going to do is we're going to identify two numbers in our polynomial here. We're going to identify this number, and we're going to call that like p, and we're going to identify the number out front here, the lead coefficient, which is a 1, and we'll call that q, okay? The rational zeros, well, actually first, before I get to that, let's identify the factors of p, and we'll talk about the factors of q. Okay, so what are all the numbers that divide 20? So go ahead and pause the video right now and think about all the numbers that evenly divide 20. Okay, so hopefully you did that, and you thought of some numbers. So you might have thought of like maybe like 1 divides 20. Oops. 2 divides 20, 4 divides 20, so it is 5 and 10, and of course the number 20 itself. Okay, but not just +1, +2, +4, +5, and +10, right? But also -1, 2, -4, -5, -10, and -20 also divide 20 evenly, -20 evenly. Let's also talk about the factors of q. Now q is just 1, so there's only one number, plus or minus 1, well 2 I guess in that sense. Okay, so these are all the factors. Now, with these factors, we're going to create a list of the possible rational zeros for f of x. And it's going to be in the form factors of p over the factors of q. And this will be true for any polynomial we come across. So we already know p's factors here, right? So it's plus or minus 1 over 1. So we'll put these two together. So it's going to be plus or minus 1 over 1. Well, what's 1 over 1? It's just 1, right? So 1. Okay. And then you can also do 2 over 1, and then we'll do 4 over 1, then 5 over 1, then 10 over 1, then 20 over 1. Of course, they're all over 1. So it's just going to be plus or minus 2 as well, plus or minus 4, plus or minus 5, and then plus or minus 10, plus or minus 20. Okay. And now we're going to do is guess and check which one of these are zeros of our polynomial. Now there's a lot to guess here, right? 2, 4, 6, 8, 10, 12, right? 12 things we have to guess. Ugh. So what I'm going to do to help you guys out here, there's a couple options. So how can we check this? Option 1. You could check by plugging in these numbers into the function to determine whether they make the function 0 or not, and that's your choice if you just want to do that arithmetic. But we can also use synthetic division, what we learned yesterday, right? So let's guess one of these here, and let's try positive 1, okay, just to kind of start off with our list here. Okay, so I'm going to guess positive 1 works, and then I'll put my lead coefficient, my coefficients in here from this polynomial. So it's going to be 1, 2, negative 19, and negative 20. Leave a space, right? Drop the 1 down, right? And then 1 times the 1 makes 1, and then we'll add the 2 and the 1 there to make, 3. And so on and so forth. We'll continue. Ooh, need to get rid of those arrows. There we go. Okay, and then we'll do the same thing. 3 times 1 gives me 3. Negative 19 plus 3 gives me negative 16. And then we'll do negative 16 times 1, which gives me negative 16. And negative 20 and negative 16, they give me negative 36. So we get a remainder, right? What does a remainder indicate? Does 1 evenly divide, or does the 0, 1, does it work on our polynomial? Does it divide, does it factor our polynomial? And the answer is no, right? We should have a remainder of 0 if it works in our polynomial. So we're going to say 1 does not work. All right, and this is the guessing and checking part, and we'll kind of put a slash there, maybe through that positive 1. And we'll say no way. All right, let's try negative 1. Okay, now I know this seems kind of daunting, but let's just keep at it here. I won't give you a ton of these, all right? I won't make it too terrible for you. All right, so negative 1. Let's plug that one. So again, let's start with 1, 2, negative 19, negative 20. Okay, so again, drop that 1 down. 1 times negative 1 is negative 1. 2 and negative 1 make 1. 1 times negative 1 is negative 1. Negative 1, negative 19 is negative 20. Negative 20 times negative 1 is positive 20. And oh my gosh, it works. Okay, so negative 1 is a 0, which means x plus 1 is a factor of the polynomial, right? Remember that this is what we actually are dividing by, okay, if this number works. Okay, now what do we do? Do we have to keep guessing and checking here? Well, you could. But remember, what's this result right here? We get x squared plus x minus 20. That's a quadratic. And we can factor quadratics. We can tell if a quadratic factors or not, right? We need two numbers that multiply to make negative 20 and add to make a 1. So what two numbers multiply negative 20 and add to make 1? Well, hopefully you said x plus 5 and x minus 4. Those are the other two factors. And again, we'll set that equal to 0 to find our zeros. And so we have x plus 5 equals 0. And x minus 4 equals 0. And so you get x is negative 5 and x is 4. Okay? Which are also in our list, right? There's the negative 5 and there's the positive 4 one. So these are also, possibilities for us to guess and check there if we wanted to. But I would really encourage you that once you get it down to a quadratic, right? Once you have these three numbers here, that means you have a quadratic. You can then, just try and factor the quadratic and don't keep guessing and checking. All right, let's try another one here. And then we'll stop, okay? Let's do one more. Okay, let's do x to the third. Let's make this a little bit different. I want to make it with a number in front. Well, right, never mind. The book does it easy like that. Okay, we'll do it that way. X to the third. Plus 3x squared minus 13x minus 15. And we're going to find the zeros. Okay, so again, we'll identify our... So again, you can look at this and see you're not going to be able to factor this, right? So we'll set this thing equal to 0. And let's see here. We're going to say there's our p. And our q is a 1 in front there. Okay, so we'll do the factors of p, which are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. You can use your calculator to help with this if you want to. And the factors of q, plus or minus 1. And so our list of possible rational zeros, again, it's going to be p over q, right? So we're going to have 1 over 1, 3 over 1, 5 over 1, and 15 over 1. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Okay, and we'll just guess and check here to see which ones work. Let's just try one and see if it works. Okay, so we'll plug in 1. We'll do 1, 3, negative 13, negative 15 over. Drop the 1 down. So 1 times 1 is 1. 3 and 1 make 4. 4 times 1 is 4. Negative 13 and 4 is negative 9. Negative 9 and 1 is negative 9. And then that adds to negative 24. So nope, that one doesn't work. All right, let's try another one here. Let's try negative 1. Ooh, sorry for that noise. Let's try negative 1. Okay, so again, we'll type in 1, 3, or type in right in here, negative 15. Okay, drop the 1 down. 1 times negative 1 is negative 1. 2, negative 2, negative 15, 15, and whoosh, that negative 1 worked again. How convenient is that? Okay, and so our results here give us x squared plus 2x minus 15, which is equal to 0. And we're going to factor this, and it does factor. We need two numbers that multiply negative 15 but add to make 2. We have positive 5. Oops. And a negative 3. And so we'll get x equals negative 5 there, and x equals 3. Those are our two solutions. Okay. Which means then that our original polynomial up here, right, it is equal to x plus 1, right, which is the what we get from that right there, and then x plus 5, and then x minus 3. Okay, but again, all I was looking for you guys to find was just the zeros for right now. So just find those zeros, okay? If you have any questions, please make sure you make a posting onto Schoology and the updates page. When I make a posting on the updates page, you can comment on those now. You weren't able to before, so I'm sorry about that. Let me know if you have any questions on the homework, and of course, message me if you have any troubles or anything. Talk to you guys later.